And now, dear students, let's talk about square roots and radicals. The square root of x is the number a such that a squared equals to x. That's the definition of the square root. Example here, the square roots of 9 are 3 and minus 3. So the positive real number 9 has two square roots. One of them is plus 3 and the other is minus 3 because 3 squared gives 9 and also minus 3 squared gives 9. Similarly for 25. When I'm asked to find the square roots of 25, I have to write that they are 5 and minus 5 because 5 squared gives 25 and minus 5 squared gives 25. While the positive square root of a real number x is called the radical and it's denoted by this symbol. So whenever I'm asked to carry out radicals, I write only the positive answers as you see here. Radical 9 equals 3, radical 25 equals 5, radical 16 equals 4. Notice that these numbers inside the radicals are perfect squares because the answer of the radicals is just a natural number. Similarly as radical 49, for example, it is 7. Radical 144 is 12. Radical 81 is 9. So these are called, the numbers inside the radicals here are called perfect squares because they can be decomposed into prime factors with even exponents, and their answer is definitely a natural number without decimals. Let's see what we have also to know about radicals. Here is a rule that says that radical a squared is a, where a is greater or equal to 0. That means a is positive. So radicals are always positive. Radical of a squared equals to a to the power 1 because indeed you have an index 2 here outside, and every time you are dividing the power inside by the index outside, and you are getting a to the power 1 by dividing 2 by 2. Similarly, if you have radical a times radical a, where a is positive surely, you can write it directly a because radical a times radical a will give radical a squared and the answer is a. If you have, for example, radical a to the power 10, then the answer is a to the power 5. If you have, for example, radical a to the power 16, then the answer is a to the power 8. So every time I'm imagining an index 2 here outside and I'm dividing the power by this index to get the final power. What if I have radical a to the power 13? All what I do is to write it as follows: radical a 12 times a to the power 1, as you know since grade 8, and the answer is a to the power 6, and a is kept inside the radical. Okay, now let's continue. I think there are here examples on simplifying powers. For example, radical 49 is decomposed into radical 7 squared and it's carried out as 7. 144 is definitely 12 squared and it's carried out as it's decomposed into 2 power 4 times 3 squared and carried out as 2 squared times 3, and so on. So notice every time I'm dividing the power inside by 2. So power 4 will be 2, power 2 will be 1. Similarly for radical 27, it's 3 squared times radical 3 squared times 3. It's carried out as 3 radical 3, and similarly here for radical 108, it's decomposed as follows. These are carried out and 3 is kept inside the radical. Radical 3 power minus 8 is 3 to the power minus 4, which is, as we mentioned before, because we have a negative exponent, it's the reciprocal of the power number itself. and 0.0001 is decomposed as 10 to the power minus 4, or is written as 10 to the power minus 4. When dividing minus 4 by 2 outside, we will get 10 to the power minus 2, which is indeed also the reciprocal of 10 squared. It is 1 over 10 squared because we have a negative exponent. Here are more rules to sum up about radicals. Given that a is greater than 0 and b is greater than 0, then radical a times radical b is written as radical a times b. So if I have a multiplication sign between the two radicals, I can put them under the same radical. Conversely, if I have two numbers multiplied under the same radical, I can split the radicals into separated radicals. Similarly, if I have fractions, radical a over radical b can be written as radical all of it of a over b. Similarly, if I have radical a over b, I can split it into separated radicals. And finally, here is a recall for radical a squared that is equal to a. Now, I'd like to let you know, or let you remember and note that we keep on saying that radical a plus or minus b is never equal to radical a plus radical b. I mean, or minus, according to this sign in the middle. I mean that if I have a minus or a plus sign between the numbers or the variables, I can never split the radicals. Let's take this example. If I want you to find radical 4 plus 9, what is radical 4 plus 9? It's surely radical 13, just adding 4 and 9. Now, if I'm going to split these radicals, to put radical 4 alone plus radical 9 alone, what should I get? Radical 4 gives 2, and radical 9 gives 3, and the final answer is 5. Surely 5 is not equal to radical 13, and that's an important example that tells me that I cannot split the radicals if I have a plus sign or a minus sign in the middle. That's a property only in multiplication and in division. And here are examples on these ideas. For example, if I have to simplify radical 5 times radical 2, I can put it directly radical 10. I can put them under the same radical. Here also I can put them radical 20, and 20 can be decomposed into 2 squared times 5, and 2 squared will be carried outside as 2, and radical 5 will be kept. Similarly, as radical 6 times radical 3, it's radical 18. Also 18 can be decomposed as follows, and so on. Here I have 3 radical 2 times 4 radical 3. 3 times 4, we multiply the numbers together and the radicals together, so we get 12 radical 6. And here are more examples. For example, if I have radical 12 times radical 8, I can decompose radical 12 as follows and radical 8 as follows. I can decompose radical, I can carry out 2 squared times 3 as 2 radical 3, and this can be carried out as 2 squared times 2. It's carried out as 2 radical 2, and finally we multiply the numbers together and the radicals together. And here are more examples similar, and the idea is repeated every time just to let you more familiar with radicals. Let's see the last example here. We have radical 2, all of it to the power minus 12, which is equal to 1 over radical 2 12. Okay, because we have a negative exponent as you see here, and then 1 over radical 2 to the power 12, when dividing 12 by 2 will be 2 to the power 6, and if we want to write it above, we can write it as 2 to the power minus 6, or we can directly put it as follows. We can put it radical 2 to the power minus 12, and finally we divide minus 12 by 2 outside here, and we get 2 to the power minus 6.